Hello and welcome to Building Context. This is a series of tech talks that we're doing on APIs and API security. My name is Chris Westfall. I head up product marketing here at Salt Security. And today, again, I'm joined by Michael Spitsky. He's our technical evangelist. Michael, welcome to the episode.
Thanks, Chris. It's great to be here again.
We're excited to have you here. We've got another great topic today. I know you just came off of a webinar and had a really interesting, bunch of interesting questions, but one of them stood out. We were talking earlier about how this is a common misconception that we've made API attacks really hard because of all the things that we put in place and all the things that we're doing on the development side, and oftentimes security through obscurity is this kind of thought that we have, right? That we've done a bunch to obscure the APIs. So why should we do anything else to protect APIs? Mm-hmm. So that's the theme of the episode today.
Yep.
So I'd love to get your thoughts on that.
Yeah, and it's a great question. I mean, I ran into this. I ran into it as an analyst, but I also ran into it as a practitioner, right? Because it's we've introduced a lot of controls, and building apps is complex, right? There's a lot of layers. What constitutes an app? We've talked about this in some of our other discussions. It's multiple things. You have front end code, you have server side code. There might be things on a mobile device. So it's complex, right? So there's almost this, it's like human nature, right? It's like, well, this seems really hard, so it must be hard for an attacker.
Right.
Unfortunately, attacker, they don't have to build the thing; they just have to break it. So they're taking advantage of kind of some things that code needs to be runnable, right? Machines need to run. Right, so you're creating the source code. You might not have access to that as the attacker. Hopefully you don't, right? Unless you got access to a Git repo that was exposed. We've seen that, but let's presume that code's locked down. You're not seeing you're not seeing the original source code. You just have this running thing on your mobile device or your access in the website. Where do you start, right? And it's for somebody that's not in security, that's kind of like, that seems like it's a black box. Like I wouldn't know, like there's nothing to grab, right?
Yeah.
For security teams, depending where they are on kind of the learning curve or their understanding of how apps and systems are built, they might recognize some of the weak links in the chain. The first thing you have to consider, right, is the API consumption patterns, right? There's a very large variety of API consumers, right? We're probably all used to, we launch a website, we're going to browse, in Google Chrome or Firefox or Edge, whatever your web browser of choice is. That's your browser is fetching web content from app servers wherever that site might be hosted. There's usually JavaScript, which is client-side code, that's going to be fetched as well, and that renders in your browser. That gives you a lot of the, the visual niceness and interactivity. But that's code, and that's actually a great example of very visible client-side code, right? So it's really trivial to extract that. I mean, there's debugging tools built into web browsers, so you can see what the JavaScript is doing.
Yeah.
If your JavaScript's calling to server-side APIs, you're going to see that in the code. The other big type of consumer is mobile apps on mobile devices, right? That's how a lot of us consume apps and data now. You're launching whatever your favorite service is. There's a mobile app on your Android or iOS device. That can also feel like a black box.
Even more
with APK. Yeah, I mean, it's an APK or an iOS file. Google and Apple have done a very good job of securing their public app stores. The reality is they're serving binaries, right? It's very much like how you might distribute patches or software within an organization. Yeah. It's just they're operating that for their consumers of their smartphone platforms. So they're serving these binaries, right? It's APKs and IPAs. Those files, they are essentially like archives or zips, right? You can extract those from a device. This is where you'll run into things like rooting or jailbreaking. There's ways to kind of pull that off the device. And quite honestly, you might not even need to do that, right? You might be able to just grab the APK from the public app store.
Yeah.
and then extract it. And I would say there is a progression path for attackers too. They might start with Android because it's a little bit easier to reverse those apps, and it's kind of the design of the operating system and how you build code for Android. It's kind of a Java-like language, and just
Yeah.
like Java, it runs in a interpreted environment. So that also means you can kind of more easily reverse that. So attackers will take the APK, extract out the binary, uh, decompile the code, and you get something very close to original source code. So you have kind of the original source, right? You don't even need that original source code if it was stashed in Git. You have the working client
Yeah.
code.
You have close
Uh,
enough, which is good enough,
yeah,
right? For
yeah, and iOS it's a little harder, because of Swift and Objective C. So you have to disassemble as opposed to decompiling. So it's a different level of subject matter expertise to understand that, but it's not impossible, right? There's a lot of guidance. OWASP has some great guidance on reverse engineering iOS apps, so it's not an unknown quantity.
yeah.
The other two is, if you follow this along enough, like IoT, certainly like connected homes, they are running their web services, right? They're calling to web APIs, just like these, traditional front end consumers we've talked about.
Mhm.
Things might be embedded into hardware, right? Like, and it's hopefully programmable, or you might be running old code, but that you might not be able to get access to the code, but you can certainly intercept communications coming out of the device. And that's where we see a lot of kind of IoT incidents and breaches, and researchers finding things in IoT code. And the other is kind of machine consumption, right? Machine to machine. This traditionally this might be like middleware, talking to some other middleware within the organization, but it
Mhm.
might also be some backend service in your network talking to another partner or supplier. Those things were pretty well controlled, right? We would use network access controls to restrict that. Maybe it's a dedicated VPN connection for that supplier, or you're using IP address allow and block lists to restrict those connections. But there's also cases where, like an application platform itself might have APIs, right? And you haven't built them.
Right.
You might not have control over them, so the platform itself might be calling out, and you just need to be kind of aware of that, right? So it's a much bigger attack surface, right? So this is kind of we've backed into what are the consumption patterns, and like, yes, it seems hard at first glance, but when you think about multi-channel or omni-channel, as a lot of organizations embrace as part of their business initiatives and digital transformation, you see this often, right? I'm going
Yeah.
to build APIs, and then I'm going to have a variety of front end consumers because they want to reuse functionality. So attackers they'll go after whichever one's easiest, and maybe they're
Right.
really awesome and they know how to attack hardware directly. But the backend APIs are almost always universal. It's rare. It's rare that an organization would maintain separate code bases for backend services because it's a lot of implementation and operational complexity.
Yeah. Well, it
Um,
seems like the misconception here again that we're trying to dispel is that we've made API security hard. I mean, you just outlined a bunch of different ways that an attacker, mildly determined attacker, can get in and start poking around and look for ways
mhm.
to manipulate the API. I would argue that API security is hard, right? Because of all these different entry points, because of the expanding attack surface, because all the different tools and all the different ways an attacker can basically get in and start to poke around.
Mhm.
We've made it really really hard to secure that attack surface and all the different types of devices that are connecting to. Um, Now I know we've covered a lot of things here. There's a lot of I guess beyond obscurity. We've tried to put some tools in place or some best practices in place in previous uh, sessions. We've talked about things like encryption, authentication, and authorization. Maybe you can talk about a little bit again about why those don't do enough.
Yeah, absolutely. So I talked quite a bit about reverse engineering client-side code to figure out that back-end logic. Um, going back to the question, right? That was kind of the origins of this topic, right,
Yeah.
Chris, from the webinar. So like, it seems hard. Why attacking
Why do
APIs
more?
is hard?
Yeah.
Yeah, and there was a very big kind of philosophy in security that still persists. That if you are encrypting data in transit using HTTPS, that's buying you security.
Yeah.
If you're authenticating that user session, you're secure. It's certainly true, right? It's raised the bar. The thing we have to remember, though, is that those are primarily not app layer, right? We're talking about a network access control, uh, particularly encrypting the data in transit. And then we're talking about something that kind of exists in the app layer, but it's authentication, right? Usually that results in some kind of authentication token or a session cookie
Mhm.
that's going to be transmitted in the session. So attackers know this, right? So there's a few ways they'll kind of go about it. I think we mentioned this on a prior discussion, but I might just phish somebody, right? Or I might use a cross-site request forgery attack,
Yeah.
where I'm getting somebody to click something and then execute a transaction on their behalf. APIs kind of make that possible, right? Because it's a predictable request. And if I can get somebody's session cookie, they can submit the request for me. Like I don't
Yeah.
have to kind of be man in the middle there. If I am just trying to um, understand the backend logic, I'm going to have some kind of authenticated session there. I might just be a regular user, and I might want to escalate privileges. We see this a lot with like broken object level authorization type of issues,
Yeah.
where you might have an authenticated session, and then in the backend, there aren't checks to verify. Well, are you authorized to access that data or objects? It can also be functions, right? This is where broken function level authorization comes in. Um, and next thing you know, you have access to way more than you thought.
Right.
Typically that would be referred to as horizontal privilege escalation or vertical privilege escalation. That's the name of the game as an attacker. You want to escalate privileges and then usually maintain persistence. So just authenticating that channel doesn't really buy you much.
Well,
And that
especially for consumer applications or any public facing application where I can sign up for an account, right? Anybody can
yeah,
be an authenticated user and then start to take advantage of bullet vulnerabilities, this broken object level
yeah.
authorization
Yeah, and I
vulnerabilities.
mean, you could script account generation too, right? We've seen that where you can hit the API that generates the account, and now I can create thousands of dummy accounts. And then,
Yeah.
we've even seen issues where, like scalability of rate limits, they just don't work. This happened in that Microsoft attack where they were forcing second factor authentication, but you could actually brute force it where it may not have kept up. We don't
Yeah.
necessarily know what was going on in the back end components, but that's the it's the virtue or value of being the attacker, right? I don't care. I'm just going to kind of hammer my way through things.
Right.
The other big mistake that a lot of organizations make because they think that the client side piece is it's this black box, nobody's going to get in it. They'll embed. I used to call them secrets, but it's any kind of authentication material. Maybe that's an API key.
Yeah.
Hopefully it's not user credentials. Like you need to be really careful where you're storing those things on device, because attackers will harvest them, right? And there's many attacks. We actually saw a report recently with healthcare apps where it was Alyssa Knight, I believe, that kind of looked at some apps, and I don't know, it was 50 apps. Many of them were storing API keys.
Yeah.
That one we've seen quite frequently, right? API keys used as a form of authentication for APIs, and it's a terrible access control because they are easily harvested either in the client side code or by running an intercepting proxy, right? Once I see that traffic, I'm going to see that key and then I'm going to reuse it. So you
Yeah.
can't depend on that for strong authentication and authorization. And then even going farther, right? Maybe you're really awesome at OAuth and OpenID Connect, and you think you got it figured out. There's a lot of attacks that target OAuth, right? It's essentially it runs on those same web channels, right? So it has
Yeah.
its own kind of flaws, and over time, right, they've improved that in the specification, but it's really hard to get OAuth right. many organizations shoot themselves in the foot there as well.
Well, I think you've given us a bunch of great examples on why the security to obscurity thing definitely is not true when it comes to APIs. I mean, there's a whole bunch of different ways that a mildly determined attacker can get in and start to probe and manipulate your API. So really need to do more than some of the stuff that's being done today. You can't just assume that we've made it hard for attackers to do their thing and therefore they're going to go somewhere else. Um, anyway, Michael, thank you again for joining today. I really appreciate your insights, and we look forward to talking to you again on a future episode. And we can dig in more into some of these topics, and we'll see you next time.
Awesome. Thanks, Chris. Looking
Cool.
forward to it.
Thanks, Michael.